Hello, this is Kenny Belfato at CIM-Tech. Here's our web page at cim-tech.com. We've got a great history. This software has been out since 1986. We've got a full range of programs. I'm going to show you our router sim software for programming. I'm going to show you AutoNest, advanced nesting, and Solid Sim, which will work from your Inventor or SolidWorks assembly. So let's take a look. I've got your assembly here. This will take a couple seconds to open up. And we'll use the material from Inventor, the part name from Inventor, and there's some pieces missing here. I usually just pick skip all there. It's no problem. It looks like it's just hardware components. And I see when you've named your parts here, you've given them part names, and you're using this as a material. You can also right-click and do part properties and put in iProperties for label fields if you like. Now, it's only one click to do the entire process. So I've opened the model. Here we've got some settings. So what to ignore, anything smaller than a 4-inch cube, thicker than this, thinner than this. It'll output layered drawings or DXFs or both. And you get to choose what geometry is on what layer. So when it sees a hole in a panel, it puts a circle on layer hole, it's white. You have all these different features that are automatically recognized. So here's the steps. One click called Solid Sim converts the Inventor assembly into intelligent drawings with geometry on different layers. So this is an automatic step. Here's called automatic feature recognition. And that takes a second, and that'll generate what's called a CSV file. Now, a lot of software will say they have 6-sided feature recognition. We do more than 6-sided feature recognition. So if you had holes on an odd face, we would pick those up as well. So here's the CSV file that it made. This is like an Excel spreadsheet or a cut list. It's got the name of the part, the material, and the quantity. And there's the panel sizes. Also, if you had your label fields, those would go here. So with one more click on that cut list, I can right-click and pick Cut with Router Sim Automation Suite. And it'll start processing the job. Before I do that, I wanted to show you some more in the assembly here. There's a feature in Solid Sim, so now we're in AutoCAD, by the way. There's an expand command here that lets you do an exploded view, and you could put a value or just use the mouse. You could do another, it's got part numbers on both sides, and you can see those little gussets have been ignored. They were smaller or thinner than the ignore section. Here's a lay flat button that lays all those parts out flat for you quickly and easily. Notice by default they're all long in the X direction. You could choose which direction the part should be rotated in. Also, which side should face up based on the side that had the most volume of material removed. So if we move this solid out of the way here, you could see we've got your, oh geez, I forget what the heck those things are called here. It found a hole on the front and on the top. And you see it's got the depth. That's how thick you drew it. So we get the full 6-sided recognition. A cam lock, that's what these are called. So it recognizes those, and you get the geometry for both operations, the top and the side operation. Now when I nest those, I'm going to turn off the horizontal routing as if they're going to be done on a separate machine. I'm just going to do the vertical routing so we can nest it. And here's that exit out of Inventor, and here's that right click on the CSV file, Cut with Router Sim Automation Suite. So that will import this list. It knows the name of the part, the material, and the quantity. And then remember, there was stuff on layer hole. You saw it whole front, whole top, left, right, outside. Those are the layer names that were generated by Solid Sim. And it also picked up the depth from your extrusions in Inventor. So it's really just that one click to do the feature recognition, then one more click to cut and nest the parts. So I'm getting a toolpath on the outside, I'm getting the drilling operations on the inside. Everything is all automated here. And I've got the software set to do both single part programming and nested programming. So I'm going to get the single part. If I ever need to do a remake, I'll have the single part available, already programmed. We're going to get labels, we're going to get cycle time reports, we're going to get nesting yield analysis. We're going to get skeleton cutting and scrap cutting. Now I already had that material, and you can put in multiple material sizes. So there's a scrap cut here on the side. I had mine set to rotate at any angle. And it just processed that whole thing in just 1 or 2 minutes. And I've got my NC code file ready to run at the router. We output for any router. You've got a PDF file that has all of your individual parts and then the nested sheet with the part numbers on there and analysis for your nesting yields. And then here's the drawing itself is saved. If you want to make changes to this drawing, you could change it. So it did a skeleton cut here. Instead of having a long L shape, we can use the software to chop that up. Or I could just erase all that and use AutoCAD and drag and drop files from another job. So let's do this. I'm going to grab a drawing here and take this part and drag it in here and put that one over here. And take this one and drag it in and put it over here. So there you could drag parts from another job or just draw your own stuff using AutoCAD. Here I'm just going to draw my own little gizmo of some sort. And I like to show, let me make that bigger there. Let's go and do an ellipse and a spline, because these are things that can cause you problems when you're drawing. If you get drawings from other people, they like to draw with ellipses and splines. Also, if there's a little break in the geometry, so I just made a little gap here. You see it. If you zoom in, if you get drawings from other people, sometimes they draw sloppy like that, right? So I took your job. I dragged 2 other parts in there. I'm going to activate the router sim software and program this little 2D drawing that I made. There's a step here called GeoShape. I'll take whatever I select and glue it together and fix the problem areas. So this one had a little gap. I'm going to put my start point up here. And at this point, too, it converted the ellipse and the spline into arc segments. So I've got these as all arcs now. It's much smoother to run that as arcs. And it's also a closed shape now right over top of the old one. It fixed that problem area. Okay. So even though I just drew this in 2D, I could start making my tool paths. In fact, let me get the information from this part here. I could pick a button that says retrieve this tool path, optionally erase it. Oh, that was a 3/8 bit in tool number 1, do an outside cutting, going through the material by 3/1000ths, or I could just plug a specific depth in right there. I'm going to turn this thing on called corner punch, because what that'll do is that'll go into these corners for me automatically. See how they drew these little bubble fillets? We give you a command to do that, but you don't have to do that. You can use this corner punch feature, and it sends the tool into the corners for you automatically like that. Ramps those in and out, so we'll get the corner feature for us automatically. Next, I'll go and switch this to inside cutting, and let's put in a almost through and then an all the way through. So there's your depth per pass, and we'll make a cut there. So that cuts in there, goes around the part twice. So it leads in, makes the first level, then slides down to the second level, cuts around, has an overlap, and leads out. So that's twice around the part with an overlap. But why go around twice? That's good for onion skins. I got a better way to do that. Okay, we can do what's called a tab at the cut start, and I could put in a percentage. So I'm going to put in 0.25 here, and this will lead in, make a tab that's 25% of the perimeter, cut around, then the overlap cuts the tab off and leads out. That's a helical motion, so the lead in is following right along the contour and right along the contour there. Much better for your tool life. This will save you time. Why go around the part twice when you can go around 1.5? So here's 1.5. We'll do that to the spline. And it's 50% of the perimeter. It's a ramped tab that ramps up and ramps down compared to the old-fashioned way that a lot of other softwares do in this kind of tabbing here, where it's, lift straight up, burns the part, plunge straight down. The plunge puts a big load on the spindle bearings. So the ramping is much better. Also, this tool path that I made here is using a tool stay down nest. So this path right here is just one lead in and one lead out, and all the parts are connected together with a little overlapping bridge with an arc motion. So the tool makes an arc out and an arc into the next part, cuts around, then overlaps and arcs out and arcs into the next part. Much smoother, much faster. That's version 3 of the stay down. It used to start and stop in the same spot. That's version 1. Version 2 had an overlap, and version 3 has tangent arc in and out. Makes it so that you can do very quick stay down nesting. These other parts, so let's say I want to copy this drill hole from your other part here. I can just pick this drill hole up and put it on my part here and here. So you can just use the copy command on any of your toolpaths. In fact, you can copy the whole part if you want. Copy the whole thing here and here. Is there enough room there? No, it looks like it'll fall off the sheet there, so I'll skip that. And then when I'm ready to resequence that, I can sequence the whole sheet, put a window around it. There's all different types of sorting, sort by area, sort by closest point. There's a ranking. So, like, for example, I have my drilling is rank 1, my inside cuts are rank 2. I can make a rank 1.5. So there's my cycle time. It adds a machine-related downtime, handling, personal fatigue. It's really going to be about 3 minutes. Here's the different tools that were used. Even though I cut a lot of the toolpath at 1200, sometimes it's 900 or 750, it shows the machine accelerating, decelerating. All of our reporting is done in Excel. And when you hit enter, it pops up the new NC code file for you ready to run. So there I took the nest results, dragged parts in from another job, drew my own 2D stuff. You can mix and match 2D and 3D in the same job, no problem at all. And then it also has in there all of your reporting features too. Let's open those results again. Here's all my labels. I've got full labeling included with this, so you get customized the labels however you want. You could put barcodes, 2D barcodes, 3D barcodes. We've got full labeling. There's even a program called Touch and Print that shows you a picture of the nest. The operator touches on a part and prints a label as he needs it. Okay, so that, or we just print them all right from here, so you've got full labeling built in. You've got all of your single part programs right here. So here's the 6 individual programs if you ever need to do a remake. You got those done. You got your individual drawings with their toolpaths on them saved here as well. And then you've got your reports for the material usage, what size sheets and how many. And then the other reporting here is a simulation as well. This is before we did the modification. So this will show the toolpath before we edited the results. It shows the drilling happening first in a closest point order, and there's that stay down nest where the tool stays down and cuts from part to part without lifting up. Okay, I did make the I can also see the results after we edited the nest as well. So you have both of those, and you can pan and tilt and zoom while it's running those as well. So you get all this results, very quick, very easy. It saves it all as a PDF file. You've got also another report here. It's saved as Excel or as a PDF, and this has got your cycle time for each part and the cycle time for the whole sheet, and then what kind of yields you got for the sheet as well. Does it print out? So we do that as both a PDF and each of the individual parts as well. Have a report for the individual parts as well. And all of that came from just 2 clicks, one inside Inventor and then one on the cut list. We got 6 individual programs, 1 nested sheet program, all the parts programmed and ready to run. That is the Router Sim software with AutoNest, Solid Sim, and advanced nesting as well. Thank you for taking a look.